Hello students, welcome back. I am Alejandro from Victory IB and CAIE Online Academy. During this video we will be discussing part B of the first problem of the 2019 AP Physics 1 exam. Now the exam as well as this problem is divided into subparts, so make sure you watch all the videos to have complete understanding of all concepts that are involved within the resolution of this exam. Let's get started.
So part B. The plunger is returned to its original position and both blocks are removed. Both blocks are no longer present in here. A uniform solid sphere is placed at point A as shown. The sphere is used by the plunger, the sphere is pushed by the plunger from point A to point B with a constant, same as before, a constant horizontal force that is directed towards the center, towards the sphere's center of mass. Oh, this is a crucial piece of information directed towards the sphere's center of mass. Okay, the sphere loses contact with the plunger at point B, same as before, and continues moving along the horizontal surface toward point E. Question: in which intervals, if any, does the sphere's angular momentum about its center of mass change? Check all that apply. Okay, so let's see what's going on here. Okay, now the angular momentum will play the lead role within this problem, and we know that the angular momentum changes only if there is a net torque acting on the system. Forces are not enough to introduce a change in the angular momentum. We need forces that are exerting a certain amount of torque within the system. So what we must do is to have a clear image of which are the forces acting in each of the stages in which the object is moving from A to B, from B to C, from C to D, and especially we must consider the specific points and direction in which those forces are acting, because what we must be able is to determine whether those forces are creating torque or not. So let's start. I have here a diagram showing the sphere and the surface in which the sphere is laying. And well, the first force that we are going to consider is the weight. The weight, it's always acting on the, considered to be acting on the center of mass of the object. The object at this part of the problem cannot be considered as a punctual object. The object has its size and has shape of a sphere. Okay, so we have weight right here represented in red, mass times gravity. We also have a normal reaction force that is acting at the point in which the sphere is in contact with the floor, right here, acting upwards. I'm just tracing this line slightly move towards the right so that you can still see the red arrow and the green arrow, but they are acting along the same vertical line. Okay, let's label this as normal reaction force, just normal or just non-normal. Those two forces will be acting at all parts of this motion. They're always present. Now, the pushing force, from which only acts from A to B, we were told that is directed towards the sphere's center of mass. How's that? Well, it goes like this. It should be acting along this point, at the left side of the sphere, acting horizontally, passing through the center of mass. Now, as you can hopefully see, those three forces that were represented up to this point are three forces acting in different directions, but all of those forces are acting along a line that passes through the center of mass of the object. So those forces are not exerting torque in the object. Now, there's a fourth force that will only be acting when the object is passing through C to D, and that is a friction force. Let me choose a different color because they ran out of colors in here. Let's use, whatever, this. Well, I go with this violet one. Now, where is the friction force acting? Of course, it's acting at this point where the normal force was acting. The friction force is or will be acting in the leftwards direction, friction force, and it's the only force that is going to be able to produce a torque. Is not acting along a line that passes through the center of mass, and that's a requirement to introduce torque, and on an object, a requirement to introduce change in the angular momentum. So only friction, right? Only from C to D. That's why, since we are asked to check all that apply, we're just going to check this one, only from C to D. But we are asked to briefly explain your reasoning. So what is it that we're going to say? Well, let's say something like this. We must say that the change in the angular momentum, let me write it down. I hope that you can read my handwriting. Change. So, this is how we can briefly explain our reasoning. Change in angular momentum is caused by a net external torque. That's a fact, a physics fact. There is friction between parts C and D, which applies torque about the center of mass of the object, producing a change in the angular momentum. So that's it. Only between regions C and D, there is a change in angular momentum.
Okay, that's it. Thanks for watching, and this is the end of part B of problem number 1. Please do watch our next video for the remaining part of the exam. Also, don't forget to register on our website www.victoryonlineacademy.com for free demo registration. I'll see you on the next video.